Hi students, today I'd like to show you how to use StatCrunch to perform simple linear regression. So I have a data set consisting of a lot of variables across multiple cities and towns, school districts in the greater Boston area. And what I'd like to do is to do a regression, simple linear, and I would like to pick median household income as my predictor variable and math SAT scores as my dependent variable. And I want to plot the fitted line, and I would like to save residuals, studentized residuals, and predicted values, and then compute. So here we have it. Here's the output. Let's first look at R squared, which is very large. It is rounded to 2 decimal places, 0.69, which says that the independent variable, median family household income, explains about 69% of the variability in average math SAT scores, and that's big. Let's also look at the regression equation. Here we have it. Let's take a look at the slope. The slope is a very small number because median family income, let's see how that is measured. Median family income is measured in dollars. So what we need to do is think not in increments of $1, not 100, not 1,000, but maybe $10,000, which means moving this decimal point 1, 2, 3, 4 places. So we're going to look at the first 4 places, maybe even round that up and call it 0015. So if we're talking in terms of $10,000, an increase of $10,000 in our x variable, an increase of $10,000 in median family income, what kind of impact would that have on math SAT scores? And moving that decimal point, it would become a 15. So an increase in median family income of household income of $10,000 would have an impact of increasing the math SAT score by around 15 points. Let's take a look at the graph. The graph displayed has a strong linear relationship between math SAT score, between median family household income and math SAT scores. Lingering on the sidelines here, I see a couple of what I'm going to call low outliers, cities and towns that aren't performing as well as they might have based on their median family income. And I see a couple of high outliers, cities and towns that are doing very well in terms of math SAT scores, in terms of what their median family, they have a relatively low median household income, and in spite of that, the average SAT scores are pretty high. Whereas these people over here have a relatively high median household income and are not performing as well as they should. So we're going to X out of that, and we're going to come over here to our studentized residuals, and we are going to sort them ascending. The smallest one is on top. The most negative is a negative 2.95. I'm going to highlight that row. That is the city or town that is furthest away from the fitted line in a negative way. It's furthest away from the fitted line in a negative respect. And anything smaller than -2 is considered an outlier. If we come down here and look at the high end, here's the one at the high end. It's this city or town, which is 196. And let me see if I can pull that up. That is, let's cursor over and find out what city or town that is. Okay, this one is Amherst Pelham, and Amherst Pelham has a student standardized residual of 3.9. It is the city or town that is of most above the fitted line. Can you see those points? This right here is the one identified as the most positive student standardized residual, and this one is the most negative. Can you see how this one is furthest from the fitted line in a negative kind of way? Done very poorly in terms of math SAT scores compared to other cities and towns that have the same median family income. And this one is doing rather well in terms of math SAT scores compared to other cities and towns that have the same median household income. So I try to summarize all of that stuff in a little document here. The one with the most negative student standardized residual was Sturbridge. It had a student standardized residual of almost a -3. The actual residual was -74.7. I tracked down the observed and the predicted math SAT scores for Sturbridge. Now, of course, if you take the difference observed minus predicted, you get the residual. The observed is a lot less than the predicted. Let's wrap it up and explain what this residual of -74.9 is really, 74.7 is really about. Sturbridge has an average math SAT score that is 74.7 points below what other cities and towns would have for a math SAT score that had the same median family income. On the flip side, Amherst Pelham had a very positive, almost 4 student standardized residual. It was the most above the fitted line. Its residual was 101. It did very well, 585, when it was only predicted to do 483.9, and hence the residual of 101. What does that mean? It means that Amherst Pelham has an average math SAT score that is 101 points higher than cities and towns with the same median family income. So if we go back to our scatter diagram, here we have it. We have Sturbridge way down here, not doing well. We have Amherst Pelham way up here, doing very well. That ends my discussion of simple linear regression.